The team is back with another episode of Topical Explainers for the second chapter of CIE IGCSE Computer Science. In this video, we will be discussing all about data transmission, and to simplify the topic and provide us with all information we need, we have Abdullah here with us.
Hello everyone. We'll be starting the chapter number 2 now, which is data transmission. This is not to be confused with data representation, which was chapter number 1. In this, we'll be discussing types, methods of transmission, and encryption of data. So we'll be just basically talking about how data is sent from one place to another. We know how data is stored, we know how data is saved, but we don't know how it's sent from one place to another. So let's just going on straight into it. So first thing that we need to know is about the data packets and the packet structure. So a packet, so whenever you're trying to send data throughout the internet, the data is divided into small packets, small pieces of data. So if you could just go to the whiteboard, let me just simply do a quick explanation for you guys. Let's just say your data, this is your data, and it includes these many bytes. Rather than sending this as a whole chunk, what we do is we take these three pieces, we send it as one, we take these three pieces and send it as one, and again and again and again. We're able to send the data easily. Now going back to the presentation, if you just go back to the presentation. So we send the data, which is a payload. We call it the payload, the piece of data that we're sending, and we have a header above it, which contains the IP address of the sender and the receiver, which gives it the direction. It tells it which receiver it has to go to the IP address. It also has a sequence number of the packet, which tells which number is the packet. So if the computer receives the third packet first, the second packet after, it knows how to sort the data into the respective ways, and we have a size of the packet which is to be sent with it. And the trailer is the end part of the packet, which has the method of identifying, which tells it that the packet has ended. It also has the error checking methods we'll be discussing later on. Now, packet switching is the method that is used when transmitting data. So in this method, what happens is that where the data is broken into multiple packets, as I've said, and then packets are sent from one by one independently, start to end, and reassemble the receiver computer. So let's just say the data that I just showed you is divided into multiple packets, and each of the packets is sent individually to the receiver. And as it has a sequence number and as it has an IP address, it would be able to go to the receiver. And then as it has sequence number, the receiver will be able to sort the packets in the right order again and be able to have the correct data back with it. Now the problem with this is that the packet now has just the IP of the receiver. The packet has to find its own way, in easy words, to go to the receiver. Now, if a packet finds the first way, it will go the first way. If it finds the second, let's just say if you want to go from one city to another, you just know you have to get to the second city. There are 3 roads going. You can pick the first one, you can pick the second one, you can pick the third one. It's depending on what you look is free. So the same way, there's no fixed path for it, and the router controls these routes that the packet takes. And each packet could take a different route, depending on which route the packet is able to find the receiver IP from. And then the packets, as you know, if they're taking different routes, some route can be faster and some routes can be slower. Some they can arrive out of order. And once the last packet has arrived, the packets are reordered, and using the sequence number of the packet, they're put into the right order. Now, types of data transmission is the packet structure, as we've just explained. The advantages of this is that there is no need to create a single line of communication. There can be many multiple ways. And once again, it is possible to overcome failed or busy nodes. So let's just say there's a way of communication, a method through, like for example, the router. If there's a wire, if you're using a wired connection, a wire is a busy or is failed. It will be able to find another way through. But if there's another method, it may not be able to find its way through. And then once again, high data transmission speed, because we're sending small packets of data, each packet is able to transmit very quickly because there's less amount of data. And it is also easy to expand the package usage. However, there are disadvantages as well. Packets can be lost. So once again, they only have the IP of the final destination. They can get lost in the communication if they're able to using very long communication methods. And once again, these are more prone to errors in real-time streaming because once again, if you're streaming, you have to wait for other packets, and if a packet is unable to arrive in the order, you can have errors. And then lastly, once again, there can be delay at the receiver end if one packet is lost or one packet is unable to reach at the correct time. So there is that. Now we'll be going into the next part, which is another method of data transfer, which is the data transmission as a whole. So there's another method of data transmission before I go into this for the packet switching, but we'll not be discussing in the IGCSE syllabus. It will be coming with A level syllabus. Now we're going to simplex, half duplex, full duplex. This is one type of thing that we need to know on serial and parallel. So let me just easily just let you guys know. So let's just assume that me and Ramesh are using trying to communicate with each other. If we have a that three, one of the first things that we need to know is our communication simplex, half duplex, or full duplex. With simplex communication, one person can communicate. Like right now, I am only able to send the data towards Umesh. Umesh is not sending anything towards me. In half duplex data transmission, we both can send data, but not at the same time. So if let's just say if I am speaking, Vyomesh cannot speak to me, but Vyomesh can later on speak to me when I am not speaking. In full duplex data communication, we can have parallel communication in which we both are speaking at the same time. An example can be computer to a printer. So mostly, yes, printer does send interrupts and printer does send errors to the computer, but let's just assume if the printer doesn't, we have a simplex data transmission because the computer is only sending the data to the printer and printer is sending nothing. For half duplex, we could have a phone conversation where only one person speaks like a walkie-talkie. Only one person can talk at a time, but we can have two-way communication. In full duplex, we can just take out a phone call. Now, serial and parallel, this is the other thing we need to know about the data transmission types. One type is the serial and one is parallel. One serial, this is just for the wired connections. The types of data transmission, those are the three, and this was line connection. We have serial and parallel. For example, if there's one wire with data sent one bit at a time over a single wire, we have a serial transmission. And if it's parallel, we have multiple wires in which one byte is sent on several wires at a time. So let's just say with too many data that we have multiple and we have one wire with one bit at a time. So we can just have a comparison first of all for it. If you have long distance communication, let's just say you're communicating from a very far away city from to another, I would recommend as a user, if you will be asking the question, you will be recommending a serial communication because it's good for long distances, especially in telephone lines. It's very cheap because it's using one wire rather than a lot of them, and rather than parallel, which is expensive because we have more wires and more amount of hardware, and it is better for short distances like internal circuits of a computer. When the data transmitted is small, for example, let's just say we have a phone call, we don't have too much of data to transmitting, serial is good. But parallel, when for example if a computer is running, we need parallel transmission will be better because we also firstly the data transmission is very can be very large, and secondly when the speed is necessary, parallel is likely to use because you can send multiple data at a single time. Serial is slower, parallel is faster. That's a comparison of these two. Yes, you need to keep these points in your mind and they could ask you questions to compare them. Now, how could you transfer data? Another way could be a universal serial bus. So it's an asynchronous serial data transmission method. Now, this USB has four cables, and you need to keep this in mind. Two are for the data transmission. Now you may be thinking two wires, all the serial communication. So each wire is for the one unidirectional, one to store and one to transfer back to the computer. So this is serial transmission for one side. And the other two wires will be used for power to give the USB power, and the fourth one will be using to earth, which is just to complete the circuit. In physics, you'll be able to understand the fact. And these have advantages and disadvantages of using a USB. The biggest advantage is that whenever you plug in your USB, it's automatically detected by the computer. The computer knows, well, I have a USB. And once again, it fits only one way. So let's just say you're plugging a USB upside down. You will not just fix it in and break it up. You can just, it will stop going in and you can just put it the right way, preventing the loss of money and incorrect connections. And has the different data transmission rates. So let's just say you want to transfer at a low speed, you could have it. You want to transfer at fast speed, you could have a USB for that. And it's industry standard. Everybody uses it. So once again, if you have something that is industry standard, that is a very big positive point because everybody's using it, everybody's familiar with it, and that's where it's compatible. So let's say you have an old USB, you have a new USB, you could have the same universal USB port, and use both of them. Even though they use different technologies, you could have the same USB port and using both of them. However, disadvantage is that you cannot have a USB which is 5 meters away from a computer because the power will not be able to reach it. And the data transmission rate is less than 120 megabytes per second, so you cannot transmit data faster than that as of now. Now, going into error detection, let's just say we're transmitting data, there is a lot of ways we could mess something up. And we need to be sure that we are able to detect errors and we're able to solve them. One of the methods is parity check. So in this method, you count the number of ones in a byte. Now, there are two types of parity checks. Parity checks is very easy if you just have a very good concentration on this part. You have even and odd. So, in this example, we are using even parity. We can use odd parity as well. So, let's just say we've transmitted this data to the user. So, this is 0 1 0 1 1 0 1 0. Now, the leftmost bit is not in the data, the 8th bit, this one. That Let me just if we can, or I'll just tell you that the leftmost bit in this example is not it is the bit that is not in the data, rather it is a parity bit. Now, when we are transmitting the data, let me just go to the whiteboard. That would be very easy to explain actually there. So if we just go back to the presentation for a second. So now this is the piece of data that we have. Now going back, now if we could go back now to the whiteboard. This is a piece of data that we have. Sorry for the low quality for this. So the data that we actually are transmitting is this, with this zero is not included. Now, while we're using even parity, we'll count the number of ones. So we have 1, 1, 2, 3, 4. Now we need to make sure that these number ones remain even if when we are transmitting the data. In this case, these are already even. So we just put a zero here so they remain even. But in the other case, what if we have a number in which this is a zero? If this is zero, we have odd number of ones. So then the parity would be one, making the total number of ones even, indicating that the data is correct. Now, in case we're using odd parity, this will be the other way around. Now, going back to the presentation, in this case, in that we're discussing in the presentation, if we can go back to it. So now we're going into the error detection methods. These are very important. And now let's just say now we have data, we know how to transmit data, but we can make a lot of mistakes, and we need to be able to make sure that these mistakes don't have a big impact on our data. The first thing that we have is parity checks, and this is a very easy concept. We have these counts the number of ones in a byte. Even and odd are the types of number of bits that we can have. So let's just say we're using even parity, we'll be counting the number of ones in a byte. The leftmost bit in this byte will be used as the parity bit. In this case, the parity bit is 0 because the ones is already even. So the rightmost 7 bits are the data and they are already 1, indicating they are even. But let's just say they are 0. There is like a 0 in place of a 1. So we'll have 3 ones. That will indicate that we need a 1 in the leftmost bit. That will make it even. So that's what we do. So if we just go to the next slide, that will even make it easier for you. So 2 bits, so this is what we do. But there is one limitation with it. And one more thing I forgot to tell you that this is using even parity. We can use odd parity, that will be the other way around. We have to make sure that number of ones are odd. In the exam, the examiner will be letting you know that what type of parity should use. And at the end of this presentation, we'll also be going into workout session and we'll be discussing some types of questions that the examiner asks you with the topic. Now, there's a problem with this method, and that is, let's just say 2 bits are changed. So let's just say this one becomes a 0 and the 0 becomes a 1. The rightmost 0 becomes a 1 and the leftmost 0 becomes a 1 as well. Now, even though 2 bits are changed, the even parity is not changed. So we are not unable to detect the error. Even though the parity is the same, the receiver knows that we will be receiving even parity and he sees, well, the parity is even, and he says, okay, the data is correct, even though data is not, because 2 bits are changed. So if even out of bits change, this error will not be identified. This is a big problem for parity. Now, in order to eliminate this error of parity checks, we use parity blocks. So for that, we send a whole parity byte in which now we're able to check the data not only horizontally for every byte, we also check the data through rows. We're not only able to check the data horizontally through rows, but we also have columns which we check as a whole to make sure that the data is transmitted correctly. Now, two more methods. Let me just do it quickly. Checksum and echo check. So in checksum, the receiver, whenever a block of data needs to be sent, the sender would calculate the value of checksum using a specific algorithm. The algorithm is known to both the receiver and the sender. So when the sender data is being sent, the receiver calculates the sender calculates the value of a checksum, and when the data is sent, data is also sent alongside the data. The checksum is also sent to the user, to the receiver, and the receiver, when it receives the value, it calculates the checksum of the value too. And if those two checksums match, then the sender is told that the data is correct. However, if they are not equal, this means that data is not correct, and the sender is asked to resend the data again. Echo check is that when the data is sent from the sender to the receiver would send the data back to the sender for verification. So when the sender receives the data back, the sender would check the data from the original data and let the receiver know that yes, the data is correct, or that no, the data is not correct. The problem is that for example, the sender sends the data to the receiver and it's the correct data, but when the receiver is sending the data back to the sender for verification, the data can be uh, have a error there. So that would cause a lot of wastage of time, and we will not be able to find out if the error occurred when the sender was receiving the error to the receiver, or when the receiver was sending the data back to the sender. Another thing that we could do is check digits. So check digits are calculated from all of the digits in the data, for example, which are XOR, and check digit will be the last digit of the code. So these use mistyping errors such as 6372, which can be written as 6379. These type of errors, the check digits are used. So we just have a digit at the end of the data, and that is calculated as a specific method, which we will be discussing later on. And in this method, well, actually what we do is we use, for example, in barcodes, we use this method in which we take the odd numbers and multiply them and with a specific number. Even numbers we multiply with them with a specific number. We add them, and then we divide them with 10 and use the remainder to be able to receive the value, and that value is put at the end, and that once again is calculated by the computer as well. But checksum and check digit are different. The checksum is a whole value, and check digit is just one specific value.
Also, just as a fun fact, check
And
digits are
Ramesh,
also
if you
used
would
in
like
credit
to
cards,
if you
right?
have anything to know,
Yeah, I just also wanted to mention that check digits are also used in credit cards at the end, the last four digits. Hello.
yes. And going ahead with this, yeah, you lagged a lot. So yeah, like I was like
Ah,
just listening to you whenever you. So you can just cut the
oh,
break, okay?
I'll
Just
just
cut the
cut the
break.
part. Yeah.
Now going into the ARQ part, this is the another method that we use to detect the errors, and this uses acknowledgement and timeout. So whenever there's a say the sender sends a data to the receiver checks the data itself for any errors. And if it sees that there are no errors, it sends an acknowledgement back to the sender that okay, I've received the data and it's all correct. However, if the data is not correct, you tell them, oh, the data is not correct, send me the correct one. But the thing that has a specific thing is that, let's just say the receiver does not send any acknowledgement. There is a predetermined amount of time the sender will wait. If the acknowledgement is not sent, it will send the data again until it receives the acknowledgement in a set amount of time. So this is ARQ. You'll be noticing the full form is automatic repeat request, even though the short form is ARQs. So the Cambridge, there is an automatic repeat query actually, or something like that. I'm not pretty sure, but the IGCSE syllabus uses the automatic repeat request full form, and the short form is ARQ. Now encryption. Let's just say we are transmitting data and we need the data to be safe. That is another problem that we have to tackle. And the thing is that we encrypt the data. Encryption is process of turning data into unreadable form. So when anybody intercepts the data, he or she is unable to make any sense of it. It's nothing for them. So there can be two types of text, which is the data, plain text, which is an original data. Let's just say this file, if I'm sending this presentation to Ramesh, this text that you're seeing will be the original data. However, the cipher data would be the encrypted data in which you are unable to make sense. Let's say that is a bunch of completely meaningless numbers and values. There are two methods of encryption. So symmetric encryption is using an encryption key, and the key is actually calculate used in calculations which are known to both of the sides that the communication is happening, and it uses that key. For example, A is equal to F, B will be made A will be made C, B will be made C will be made the next letter, and so on. So you change every single value to another value, and you have a specific amount of key. And the encryption key, the same key is used for encrypting and decrypting the data. Symmetric is pretty simple, but asymmetric is a bit more complicated and it's more secure. So it uses a public key and a private key. A public key is that, let's just say I'm transmitting data. I have a key made available to the public, made available to everyone, which is letting them know that this is my public key. And a private key is available only to the user I'm sending the data to. So the receiver would have the private key and they would send the public key to the sender. And the sender can encrypt the message with the public key and the data can be on the decrypted using the private key. So the thing that will be happening is that if I am the sender, the receiver that I'm sending data to has the private key and they will send the public key to me, which is available to everyone. Now sender can encrypt the message with the message that I will be sending will be encrypted with his public key, not mine, with his public key. And when the data is received on him, he has the private key which decrypts the message from his public key. So the public key will be used to encrypt the data. Using my encryption method, he will send me his public key, which is public to everyone. So in that method, I could encrypt any data. The public key using, for example, I have a key and Zumesh has a key. We both have two keys, public and private. Using my public key, Vyumesh has to send me some data. So I'll just give my public key to Vyumesh, and Vyumesh will encrypt the data using my public key and send the data to me. Now the data that is encrypted cannot be decrypted by anyone except me because I have the private key of that data. So using the data that I have gotten, I would decrypt it and bring it back to the normal form using the private key that I only have. So this is how you're able to send the data through asymmetric encryption. So that is it for this chapter, and now we'll be just going into the workout session, and Ramesh will be with us, who will be guiding us through this. And so we'll be starting off with the 047 questions, summer 2015, paper 1-2.
Sure. So as I see here, the system uses an even parity, and what we're basically being told is to see that look at the received byte and say if it is correctly transmitted or not. Looking at the first byte, right? The leftmost bit is going to be the parity bit, and that's a 1. Okay. And if we look at the right, I mean, if we look at the right, it's they've gotten 2 ones, right? So that's an even number. But if we can look at the entire bit, there are 3 ones, so that's an odd, right? It's not even. So in that case, I would say that the byte is transmitted incorrectly. And if you look at the second byte, right? Let's count the number of ones that we have. It is 1, 2, 3, 4, 5. 5 is an odd number. So that means that they did not change the parity bit to 1. And so it shows that the byte has been transmitted incorrectly, right? But if we look at the last option, right? 0, 1, 1, 0, 1, 0, 0, 1. Let's count the number of ones that we have here. There are 4 ones, and the system uses an even parity, which shows that the byte was transmitted correctly according to the parity bit.
And if you go to the markings, you are able to see that the first two were incorrect, the last one was correct. Now, this one is once again the continuation of that question from the past. So if you could go to the whiteboard, so we'll be able to do it even easier, in even easier way. Ramesh, I would love you to answer this question.
Sure. So it says that the parity bit is used to identify which bit has been transmitted incorrectly in the block of data. So basically, the word flowchart was transmitted using 9 bits of data, 1 byte per character. A tenth bit, the parity bit, was also transmitted. The following block of data shows all 10 bytes received after transmission. The system uses even parity, and column number one is the parity bit, right? So column number one is the parity bit, and the 10th byte is also the parity bit byte, right? So one of the bits has been transmitted incorrectly, right? So write the byte number and the column number of this byte, right? So we have to just basically, I would go row by row, let's say, right? So in the first one, right, for byte number one, I would see that it's even. That's correct. For byte number two, it's even. Byte number three, it's even. Byte number four, even. Byte number five, even. Byte number six, even. Byte number seven. Oh, okay. We've found a problem here. Look at byte number seven. It only has 3 ones, right? So I would flag that as incorrect transmission, byte number seven. And then what I would do is I would go to the columns, right? So I'm going to check for each column and then check it with the parity bit underneath. And it should be even, combining all of them. Oh, this is going to be difficult. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6, 7, 8. Okay, column number one is check. Column number two is check. Column number three, it should be checked because there are 10 ones, right? Column number four, it's 1, 2, 3, 4. That's also check. Column number five is going to be 1, 2, 3, 4. That's also check. Column number six is going to be 1, 2, 3, 4, 5, 6, 7. Oh, okay. We found another anomaly. Look at byte number, the column number six. Sorry, it has 1, 2, 3, 4, 5, 6, 7 bytes. 7 ones, right? So that shows us that the problem is actually on byte number seven and column number six.
Yes, yes, and that's how you calculate the values. And if we just go to the next slide, we'll be able
Yeah,
to see
let's
what
check
the
the marks.
marking scheme has the answer, and it is column seven, byte seven, and column six, which was our answer. So now once again we'll be continuing with this question. It's a pretty long question. So Vimesh, once again, if you just continue with it.
Sure. So I would say that the I would go to back to the letters, right? So what we found the issue was with byte number seven, right? So I would say that in byte number seven, right, it would transmit it as an odd parity because there were 3 ones there, right? And I would also say that column number six has again odd parity, right? Because there's 7 ones, I think. Let me just check.
Yes,
Yes,
there
there
are
were seven
seven
ones.
ones.
Right. Yeah. So that's an odd parity, right? And the system uses an even parity, which tells us that the issue would be, you know, in the intersection of these both.
Now on to the next part. We need to convert it to binary. We have studied that in chapter one. We'll just put the imaginary 1, 2, 4, 8, 16, 32 below it. Now, this is not talking about any complement, so we'll just be directly converting the value. So one is not one is R0, 2 plus 4 plus 8 plus 16 plus 32 plus 128. Whatever the answer you get will be the answer of this value. The next part is that the parity check may not identify that the bit has been transmitted incorrectly. Describe one situation it could occur as we discussed. If two bits are not in a single byte are not transmitted correctly, that will not be affecting our parity at all, even though there is an error. Let's just say the upper byte has 1, 2, 3, 4, 5, 6, 1, so it's using even parity. Let's assume that. and we have the first two values changed, so it will become 0 1. The value, the answer is completely changed, even though the parity has not changed, which we will not be able to identify the error for ourselves. Once again, let's just see letter A has been transmitted as an odd letter A byte, which is the byte 7, has been transmitted as an odd parity 3 ones, as Azumate said, column 6, 7 ones. So intersection becomes a point. 190, which we didn't calculate, we just summarize it for you. And the last one, two bits are interchanged, one becomes 0 and 0 becomes 1, they would be able to check the parity value. Even if 2 1 becomes 0 or 2 0 become 1, they will not be able to tell the difference. So now we'll be going to the next question. This is from 2210 syllabus, which is the GCE syllabus. Although we have studying IGCSE syllabus, the IGCSE syllabus has been updated to add these contents, and that's why we're using the GCE syllabus where this has been tested. Summer 2017, paper 1 2, where this is a type of question they can ask you just to summarize the parity check, calculated checksum, and ARQ, in which you have described them, 2 marks each. So we'll just go straight back to the marking scheme, and Vivek will be there to explain you all of the marking scheme.
Sure. So I actually remember this specific question too. I think similar to this, I basically used it to summarize all of my points for each check. So, for example, for parity check, I would just go with a parity bit is added, right? Again, it says 2 marks per description, so it's pretty easy to get enough. I would say parity bit is added, and it basically counts the number of ones to see if they're even or odd, right? And if parity is incorrect, error is detected. Simple as that. For check digit, I would say that a digit is calculated from the data, right? I mean, in a few of the questions, you would actually see using the modulo of to calculate digits, but I don't think so. That's part of the IGCSE questions. But you could just say that the digit that is calculated from the data, and it is recalculated when the data is received, and it is compared to check for any errors, right? It's always good to actually mention 3 points, even if you think that it might ask 2 points for each of the sections. It's better to have more points in the case that one of them is invalidated, right? Let's look at checksum. It's just basically a value is calculated from your data and is transmitted along with it, right? And then at the end, when in the receiver's end, the value is calculated again and it is compared to check for any errors. And for automatic repeat request, right? So basically, it uses acknowledgement, right? A check is performed on receiving data. Error control protocol is used. Check performed on received data, and error is detected. If error is detected, a request is sent back to resend the data, right? And when the resend request is repeated until the data is actually sent correctly. So let's say if it requested back again and it still showed some error, it's going to request it until it actually receives the correct data, right? And so it basically uses this is the main thing. It uses sends an acknowledgement that the data is received, and if the data is not received within a time limit, it is resent. Yeah.
Now, now we're going to the next part, which is the next question, which is discussing the serial, parallel, and duplex data communication, and we may should be continuing it once again.
Sure. So here I can see that the computers can transmit using two different methods. Describe three data transmission methods given below, right? So talking about serial data transmission, right? It's basically data is transmitted 1 bit at a time and using a single wire, right? That's what I would go with straight away from those 2 points. Parallel data transmission, on the other hand, it's multiple bits sent simultaneously using multiple wires, right? And then for duplex data transmission, data is sent at both time in both directions and can be also sent simultaneously. That's what makes duplex data transmission different than half duplex, let's say. So it's also a very important thing to mention that at the same time or simultaneously, it is important.
Now, going to the next part, this is the third part of the same question, which is data transferred over network is encrypted to improve data security. In this, we're talking about the system uses 64-bit symmetric encryption, and we will explain how encryption improves data security. So, It's basically asking why do we need encryption? How is it improving our security? So the answer is simple that the encrypted data is meaningless. It's just a bunch of random numbers and text which does not have any specific meaning or anything for the person who does not have the key, and if the data is hacked in the middle of transmission, it will not have any value. So that is it for this episode.
And yeah, thank you for tuning in. We hope that you had a great understanding of the concept. You could get hold of the ZNotes notes on the ZNotes website, and our social media handles are on display. So connect with us and feel free to drop any of your questions. And yeah, that's it. See you in the next upload. Thank you.